Thanks for viewing this self-paced learning module, created to support suppliers with Project iTrace implementation. In this module, you will be taken through stations 8 and 9 of the Project iTrace railroad map, data, and barcodes and RFID. This video steps through the options for capturing GS1 identification keys such as GTIN and GIAI into barcodes and RFID. This will include examples of GTINs and GIAIs, as well as additional data elements, and support suppliers with implementation of Project iTrace. The foundations to Project iTrace is GS1 Standards application and use. The GS1 Standards framework sits across three main channels: identify, capture, and share. In this module, we'll look at aspects of capture, capturing and encoding identification numbers and data into GS1 data carriers for application to components, parts, consumables, and assets. GS1 identifiers are captured using GS1 barcodes and GS1 EPC RFID, global standards for carriers that provide accurate and automatic capture of data. GS1 has a family of barcodes, developed and used across various industries. The rail industry is seeing preference towards GS1 Data Matrix, a 2D barcode that can carry a wealth of information with an extremely small footprint and the ability to be applied in many application formats, from print to laser etching. Also, some linear barcodes may also be applicable and utilized. GS1 standards can also be applied into RFID technologies, providing an extra level of operationalization with the tracking of parts, components, and assets. Out of all the GS1 barcodes, there are three that are most likely to be suitable for suppliers to the rail industry. EAN or UPC linear barcodes are most commonly seen in retail at point-of-sale environments. This could include products that are ranged by retail stores on products of a consumable nature more so. The GS1 128 is also a linear barcode, which may see application on boxes or cases, such as a 24-pack of consumables. It could also be applied to parts and components and assets. However, its size and limited method of application, printed labels and packaging, means it is unlikely to stay with the product for its lifetime, so does not suit many parts and components used in rail. Last of all, the GS1 Data Matrix is a 2D barcode and is seeing preference for the marking of parts, components and assets that have a longer life cycle. The ability for direct part marking of a component, such as laser etching, means the barcode will last the lifetime of the part itself, allowing for identification into the future. EAN UPC barcodes are typically for products transacted via retail point of sale, often consumables, and some parts. Barcodes such as the EAN13 can be used throughout the entire supply chain. Example, lubricants, engine oil, products that could also be found in automotive accessory retail outlets. The EAN13 or the UPCA is not recommended for products that are never likely to cross the retail point of sale, such as bogies, wheel sets, and pantographs. These barcodes normally form part of printed labeling or packaging and can only have a GTIN encoded. A GS1 128 may be used to identify parts, components and assets using GTINs and GIAIs, and have the ability to have additional data encoded, such as batch, expiry, manufacture date, serial, and more. GS1 128 barcodes are not commonly used at point of sale, but may be seen on boxes or cases that contain multiple units for individual sale. Their use is largely seen in many non-retail environments and in industries including rail. The GS1 128 is also used for the allocation of SSCCs, Serial Shipping Container Code, used by companies to identify a logistics unit. The GS1 Data Matrix is a 2D barcode that is preferential for marking parts, components and assets. This is for a few reasons. Size. The GS1 Data Matrix can be produced at an extremely small size, a few millimeters square, suited to small components and parts. Durability. With error detection being part of the makeup, any degradation to the barcode means it will still likely scan, unlike many linear barcodes. Marking methods. Unlike linear barcodes that usually require printed application, the GS1 data matrix can be applied in several ways through direct part marking, using methods such as laser etching. This means the barcode is more robust for a much longer period, often for years or decades, supporting long-life parts and assets management. The GS1 data matrix can also have additional data encoded, such as batch, expiry, manufacture date, serial, and more. With regards to data encoded into these barcodes, the following should be noted. EAN UPC barcodes, only a GTIN can be encoded. GS1128, a GTIN or GIAI can be encoded, as well as more attribute data. GS1 data matrix, a GTIN or GIAI can be encoded, as well as more attribute data. So, how is additional data encoded, and what is the scope of the rail industry with regards to additional data in barcoded parts, consumables, and assets? Let's take a look. Here we see a GS1 data matrix. Scanning this barcode would show that it actually contains, as well as a GTIN, an expiry date, a batch number, and a serial number. So, how is this achieved? Well, a visual indicator is the brackets and digits you will now see appear. These are commonly known as GS1 application identifiers. Just like a phone number's area code can be added to identify which state you're calling from and to, AIs work in a similar way. 01, a 14-digit GTIN precedes the AI. 17, an expiry date follows the AI. 10, a batch or lot number precedes the AI. And 21, a serial number follows the AI. This standardized, structured information allows scanners to easily interpret each element of data and enables systems to feed these data elements into different areas of applications such as ERP or warehouse management software. There are more than 100 application identifiers which your business can use to identify additional data within a barcode or RFID tag. Here we see AIs 01 and 8004 for encoding GTIN and GIAI, which act as globally unique identifiers. Now we see some additional production identifiers that will be used across rail. You as the supplier need to determine which data elements you will apply. For example, a motor. This would require GTIN plus serial number to identify one motor from another. Rail spikes wouldn't need to be individually identified, however, identifying production batches of rail spikes with a GTIN plus batch would be a good idea. To appraise this within your own organisation, refer to the Rail Implementation Guideline Section 3 regarding product requirements. A link is shown at the bottom of this slide. Now we have seen how to capture a globally unique identifier and additional data elements using GS1 application identifiers, and also some of the common barcodes used across rail. It's now time to determine the marking method. That is, how to apply the barcode. This will be detailed in a further training module video, Station 10, Marking. For any queries or unique capture scenarios, contact the iTrace team at GS1. The Rail Implementation Guideline details why and how you should go about adopting industry-agreed standards for identifying and marking MRO items, such as consumables, capital equipment, rotables, and non-rotables. Review of this document is a prerequisite for any iTrace implementation. GS1 offers further training options to support Project iTrace implementation. This includes a 30-minute webinar that helps organisations understand the background to Project iTrace and the key steps to get moving with your implementation. There are also more short video tutorials like this one, detailing specific steps of implementation, offering self-paced training support. And third, a 2-hour online interactive training session covering how GS1 standards are to be implemented in the Australian rail industry through the Project iTrace initiative. For more information on these training opportunities, visit the GS1 Australia website or email the iTrace team at GS1. Thanks for watching.